Our next speaker is Alex Sparrow, who is the founder and MD of UK Hempcrete Ltd. Again, another partner in the CHC3 project. And Alex's talk is going to be on ISO Hemp Blocks, hempcrete at scale for the mainstream construction industry.
Is that what I called it?
Yes.
I should have put that on the slide, shouldn't I? Thanks for the invitation to come and speak to you today. So UK Hempcrete is my company, and ISO Hemp is our partner in Belgium who make hempcrete blocks. So I'm going to tell you a little bit about their process later on. And we're shortly going to be manufacturing those blocks in the UK. And that's why I've come to talk to you about them, because you guys are hopefully our supply chain, or those of you who are farming. This is a house that was built by us in 2018 on mainland Orkney, where there is quite a lot of water around. And I 100% agree with Mike's diagnosis of most of any problems you'll find in a hempcrete or hemp lime. The terms are interchangeable at the moment, really. House will be to do with moisture. Okay, so just a little bit of background. Most of you know me, I think, already, but I'm halfway through my second decade of building with hemp and other biomaterials in the UK, and we as a collective, we the country, England, are approaching halfway through our third decade of building with this particular material. So that's a thing to be celebrated. So that's an inside shot of the same house as we were building it up. So you can see the ISO hemp blocks that have been built as an internal skin around and tied back to the lining and tied back to the structural timber frame of the building, because hempcrete is not a load-bearing material. You can think of it as a kind of mass walling insulation material made by mixing building lime or a formulated building lime with the raw stalk of the hemp plant, which is chopped up as an aggregate in that material. Okay, this particular house had an internal lining of precast ISO hemp blocks, and then an external skin of wet mixed hempcrete that was mixed and installed on site. So you kind of combining the best of both worlds. Okay, so as I was discussing with Mike in the break, when you're wet mixing and casting the material on site, you then have a drying time on site, and it's sometimes any problems that do arise will arise because builders are kind of wanting to speed that process up, mainly because the client wants to be in for Christmas. And so this kind of combined build-up ensures you against that. So you still have the benefits of this single cast homogeneous material around the outside of the building. So you'd have no thermal bridging through different elements of the building. And it's very easy to make airtight by applying a lime render, which you saw in the first photograph, but the inside is already dried. So if necessary, while the hempcrete's drying, you can fit the windows and plaster and move in. Doesn't slow progress on site. It's not just us that are using hempcrete blocks, and in fact, Mike will recognise this photo. This was a certainly the earliest example I've got a photograph of a project involving hempcrete blocks, and the company will be familiar, I'm sure, to lots of you in this part of the country. I was actually born about 4 miles down the road from Southwold, so it's my kind of home brewery, if you like. So I think this is 2006. Would you agree with that? Yeah. So a couple of years before I started, and this was built by a company called Lime Technology. And again, that building is a mixture of hempcrete blocks and cast on-site hempcrete. The reason that brewery companies and other food companies, the Wine Society in Stevenage also has a hempcrete warehouse. The reason those companies are really interested in using it as a material is that the fabric of a hempcrete building gives it some exceptional thermal and moisture performance characteristics, which enable a kind of the fabric itself passively delivers a sort of regulated humidity and temperature inside the building, which has obvious benefits if you're storing wine or beer or food. Here's a more recent example. This is a cafe building that we built in, well, we didn't build the building, we built the hempcrete walling system within it in the park in Lincolnshire a few years ago, 2017, I think. Which again is built using a combination of hempcrete blocks without the cast hempcrete this time, because we don't consider cast on site to be suitable for kind of commercial scale projects because of that drying time, really. So in this case, it combines hempcrete blocks with a wood fibre board external insulation shell, which is then either rendered or brick clad, depending on the elevation in there, really. Another slightly earlier project, this one, if anyone's from Yorkshire, you might know this one. So this is William's Den up in the East Riding, which is essentially a farm diversification project, and it's a big kind of adventure play area. It's a great day out with the kids or grandkids if you're up that part of the world. And the whole, it's not just indoors, it's outside as well, and it's all themed around natural materials. So again, hempcrete blocks and wood fibre used on that project. So as I wanted to tell you a little bit more about the block system, as Mike was saying, I think you probably covered most of these off, Mike, but the hemp lime or hempcrete has some really exceptional characteristics. The main one being thermal performance. So we're going to talk about that in a little bit, and I'm going to embarrass myself by showing a slide that probably originated from the University of Bath a few years ago. Not really realizing that Mike was going to be in the room today. Yeah, essentially, so due to the fact that lime is used as the binder, one of the really interesting things about hempcrete is that it doesn't need any additional chemical treatment for rot resistance, pest resistance, or fire resistance. Okay, so that's a big one, and clearly everyone in the construction industry has had their minds focused on fire over the last few years, sadly, since Grenfell Tower. As Mike was saying, the hempcrete envelope itself will passively regulate internal humidity, which has lots of health and well-being benefits for building occupants. The thermal comfort is really exceptional. So I was down in South Devon on Wednesday, visiting a building down there that was built last year, and walked in, and the internal the temperature was like this building today. And I said to them, "Have you had the heating on at all yet?" And they said no, which was the expected answer, because everything we've ever built just sits there at between 17 and 19 degrees centigrade all year round. So it can be -10 outside, it can be +30 outside, and it just stays within that range. And that's just from the fabric performance. So when you start to think about kind of passive solar design within the design stage, you can kind of increase that a little bit if you want to. So as Mike was saying, one of the key things that we've all been working on over the last few years is reducing embodied carbon within construction products. Clearly, the thermal performance of the building reduces operational carbon, so the fuel that we're using to heat buildings, quite significantly. And as I'm sure most of you are aware, globally, I think about 39% of global CO2 emissions are associated with buildings. Okay, so and out of that 30%, about 40%, about 2/3 are the operational emissions associated with running the building, and the other third is to do with the embodied carbon, so the carbon that gets emitted in the extraction of raw materials and manufacturing of products. Okay, but in this case, 80% of an ISO hemp block is raw hemp stalk. Okay, we also have some sort of manufacturing efficiencies that help us to reduce carbon. So any kind of unused or sort of material that isn't fit for the market can be crushed and added back into the manufacturing process. The carbon footprint of hempcrete obviously varies from company to company. Every manufacturer will be assessing their own particular supply chain. So for this particular product, there's a net 75 kilograms of atmospheric CO2 that gets locked up in a cubic meter of hempcrete blocks. And that is to do with, largely to do with the amount of CO2 that the hemp plant absorbs during its growth phase. Relative to other plants, it's growing very fast, growing sort of 3 or 4 meters in 3 or 4 months, and it's holding itself up by very rapidly absorbing carbon and laying it down as cellulose in a really woody stem. Okay, so we're going to find out exactly how much, because haven't got it on my slides today, but I'm also a part of the CHC3 project, and our part of the project is that we are, together with other partners here in the room, doing some in-depth analysis of the carbon in hemp biomass when it's grown, and different varieties as they're grown around the UK. So, as Mike was saying, a really important part of taking a construction product to market is thorough testing and certification of that product. I'm not expecting you to kind of read all of the bits out of that today, but have I got a laser? Oh yeah, that works. So just a really important one, essentially. So this is the reaction to fire without any lime render or lime plaster on the product, and that's typically how you use it. You create the wall from the hempcrete blocks, and then you would apply an internal lime plaster and an external lime render, or any other finish you want, directly onto the material. So with a plaster applied, it gets an A2 reaction to fire, which is the highest you can get if there's any biomaterial at all in a product. And then in terms of fire resistance within buildings, or a fire break, 120 mil block with plaster gives you 60 minutes fire break, and a 200 mil block gives you 2-hour fire rating. Okay, so as you may not have picked up, the bulk density, the weight of the product is quite heavy for an insulation material. So 340 kilograms per cubic meter in this case, which is a sort of typical figure for hempcrete in walls. And what that gives us is, where's it gone? The specific heat capacity. I'm missing that. Maybe it's not on this. Basically, the thermal performance is not just due to the U value, the insulation value. It also, because of the line binder, has a mass. And for that reason, the phase shift, this line here, is this is in hours. The phase shift is the time that it takes energy to pass through as heat to pass through the envelope. Okay, so whereas if you had a very lightweight insulation material, like for example PIR or any kind of lightweight insulation material, 200 millimeters of that material would have a phase shift of about 3.5 hours. Okay, so that's why if you kind of work in a modern, well-insulated building, you'll be very comfortable till about lunchtime during the summer, and then the building will start overheating because the heat after that time has passed through the envelope and is now inside the room with you, and your insulation layer is now working against you, and you're cranking the aircon up because it's really uncomfortable. Okay, so if we take the 20 centimeter or 200 mil block and we follow that down, you'll see that the phase shift is, I can't actually read it from there, I think 13 hours. It's usually 12 to 13 hours. So the interesting effect that gives us, with due reference to Mr. Lawrence, was demonstrated really neatly in a paper from the University of Bath many years ago, about 2010 or something like that. where they built two experimental buildings, one filled with PIR insulation and one with hempcrete. So this was 200 millimeters of hempcrete cast around a timber frame. I'm not allowed to build walls that thin in the UK because it doesn't meet current building regs for insulation value at all. We're building walls that are nearly twice that thickness. But you can see that this unheated building, or left unheated over a certain length of time, you've got the external day-night temperature in purple there, fluctuating as you would expect. On quite helpfully a 12-hour cycle, okay, with diurnal temperature change. And then the internal temperature inside that unheated building is staying much more static within a kind of 15, 16 degrees centigrade range. Okay, and that's the sort of visual sort of underlining of that effect that I was talking about, of that static internal temperature that we get in buildings. So a little bit more detail about the products themselves. As you probably saw from the tech sheet, they come in a wide range of sizes. That's intentional to make the whole system a bit more flexible. We'll come back to these interesting looking blocks with holes on in a second. So they're range in size from 7 centimeters, which might be much more appropriate for a retrofit context, right up to 360 mil, and those can obviously be combined in a lot of different ways. I've included, just because it's not included on the tech sheet, some sort of U value information, okay, and they've highlighted there the ones that they consider to be passive, okay, and there's a lot of kind of focus on passive house as a concept in the UK because it's been developed over many years to have very low operational energy, okay, but passive house is a certification system designed for lightweight insulation. Okay, and if you're using lightweight insulation, that's a logical place to get to. You need to have stuff that's super insulated and super airtight to maximize the potential performance of that building. But the one issue with it is, and this is partly due to the modeling software that they use, but the one of the issues with it is that because it's a lightweight insulation, it has a tendency to overheat in the summer. Okay, and you will find that in passive house design, there will usually be a big concrete floor slab or something to put some mass into the building as a heat dump during the hotter months. And obviously people will use purge ventilation to sort of release the heat. With hempcrete, that thermal mass is spread equally around the envelope of the building. Okay. So a little bit about the manufacturing process. So ISO Hemp have been going for about 9 years. They've recently, about 2 years ago, built their second factory. So their first factory had like 1 million blocks a year capacity, and they've now stepped up to a 5 million blocks a year capacity. So let's break that down. So 3 raw materials: water, hemp, and a formulated lime binder. As I said before, any blocks which don't meet this kind of automated QA standard will get crushed. They also, and whoever was talking about companies capitalizing on these things, so as well as crushing the material and putting it back into the next manufacturing cycle, they've also realized that crushed but pre-limed hempcrete is quite a good loose fill insulation material, so they have a separate product which gets sold in that form. The lime is a mixture of air lime and hydraulic lime, okay, roughly 50-50 within the mix of the binder, and there's a huge silo, 2 huge silos on site for storing that material, which gets automatically fed through to the mixing facility inside, obviously. So the three materials, the lime, the hemp, and the water, come together and get mixed, and then that material is dumped into an automated production line, which spreads it into molds, and a sort of robot arm comes over and presses it. and then any sort of there's a stage where they get measured, any non-compliant blocks get pushed off by the robot, and then those blocks move along and are sort of stacked neatly on a pallet by another robot, and then the pallet itself gets lifted by a machine into a curing room, and after 24 hours of initial hardening, which is a function of the hydraulic line, they will then get stacked onto pallets, and a full pallet is then set outside, is covered, stabilized and covered and set outside to go through the drying process, and the air lime in the mix then reabsorbs some of the carbon that was given off when that lime was burnt. Okay, and then finally, after a couple of months drying time, they get delivered to site, and they're used in a range of contexts. So here's another domestic building with a timber frame and hemp blocks being built up around it as the finished article. Steel frame and hempcrete blocks. This is where the different sizes of block come in very come in very handy, because you can kind of design any sort of bits where you're building around the steel frame structure can easily be done with that. That's the same building again. They're also suitable for a CLT structure, which kind of had a real popularity a few years ago. I think people are now realizing it's not quite as sustainable as they hoped it would be. But there you have a CLT structure and hempcrete blocks being built up the side, and there's the finished building. We also, I'll run through this a bit quickly because I'm not sure about time, but these funny shaped blocks were to do with this system. So on the continent, it's less usual here, but on the continent, even in domestic buildings, it might be more usual to cast a rebarred concrete frame as the structure in a building. And in terms of scaling hempcrete in scale house building, that's quite has quite obviously it impacts your carbon footprint, but it has the ability to make the build a lot cheaper. So you have blocks that are deliberately formed so that you can build with the hempcrete blocks, which are self-supporting, and as you go up, you cast a rebarred concrete frame inside. So a couple of examples of that on site, so you can get an idea immediately how that works. And then this is our first Hempro house in this country, which was designed by an architect called Cathy Curran in London a few years ago. It can also be, as I was saying earlier, be used in retrofit, either as external wall insulation, because they're hempcrete as a material is very resistant to water, as Mike was saying, as long as you don't trap water in it. It can also be used in internal wall insulation contexts, and this is a couple of shots of an apartment block in Brussels, so commercial retrofit context basically. So thank you, and I don't know if I've got time for questions, but I'm here all day, so you know where I am.
Thank you, Alex.